Good morning, friends. In today's lecture, we will discuss about introduction of stress and strain. We already discussed these all topics on in diploma, and today we will discuss it in detail. So, before starting off what is stress and strain, we must understand the load. So, we have if I have an object and I applied a force, then I need to know that which type of force applied on this object, so that we can find the stress and whether it is safe or not we can calculate. So first is a tensile load. In tensile load, if we applied a load in this two direction in this way, opposite to each other, then this load is known as tensile load. Okay, if I applied on opposite direction. Then second load is if I applied a load to compress the object from both direction. So this type of load is known as compressive load. And third load is shear load. If this is object and I applied load like this to opposite force, but both have they are not collinear or not acted at same axis, like in tensile load and compressive load. So this type of load is known as shear load. And last one is bending load. If this is a object which is supported by a two support like this, and I applied load, and it will be bend like this. So this is known as bending load. Okay, so this is the type of load. According to that, we will do analysis on any object. Now our main topic, let's start. It is stress. So what is stress? Stress is denoted by sigma. So here we will see the equation of that. Force is equal to force stress denoted by sigma, and is equal to force upon area. So if we have an object and I applied load like this, it is tensile load. And if it is a rectangular, the block has a rectangular cross section, then force P is we write the force P in here, and the cross section of this object is A. If it is rectangular cross section, then we will write the cross section area of rectangular, and this will be stress. And always if we applied load in any object, then always there is a resistance from an object. If this resistance is above its safer limit, then it will be break. So here we find the stress, and according to that we can decide that whether this object will sustain in this force or not. So for that we will find sigma is equal to force upon area. The unit of force is Newton, and unit of area is mm square. So the unit of stress is Newton per mm square. Next is strain. Now if this is the object and we apply tensile load like this, and due to load this object is elongate. So suppose at initial stage the length is L, and due to elongation the length is increased by delta L. So our new length is delta L plus delta L due to load. So original length L upon change in length delta L upon original length L is known as strain. Strain is denoted by epsilon. Okay, so this is the epsilon. Epsilon is delta L upon L, and it is unitless quantity, as the unit of delta L is mm and L is mm. So strain is unitless quantity. Now Young's modulus. So we have stress and we have strain. So if we write like this, stress upon strain, so this is denoted by Young modulus capital E, which is also known as modulus of elasticity. And this is stress strain curve. This stress strain curve we can get from the universal testing machine by performing a tensile test on the given object. So this is the stress strain diagram for mild steel. If we apply a load on an object, so this is the reaction of stress and strain. We can plot a diagram on that. Initially we applied a lower force, as stress is force upon area and strain is change in length upon L. So as we apply the force, the delta L will be changed. So and we can measure the elongation of object in universal testing machine, and according to that we can get this type of graph. So initial condition, we do not apply any load, then gradually we are increasing our load like this. So you can see up to a point the stress and strain is linearly proportional, and we can find the Young modulus from this curve. So it is the Young modulus is slope of this curve, as stress is proportional to strain, and we will see one law on this. It is Hooke's law. So Hooke's law says that stress is proportional to strain up to elastic limit, and then slightly change in curve up to B and C point. The C point is upper yield and D point is lower yield. A point is proportional limit, B point is elastic limit, C point is upper yield, and then we see small downward. This is the lower yield point, and then if we applied load, then up to E point any object can sustain, then it will break. So F is the fracture point, E is the ultimate tensile stress, and F is the fracture point. So this is stress strain diagram. Thank you.